Hello everyone. Today we are going to see about how to compute DFT for an given sequence using DIF-FFT algorithm. DIF is nothing but decimation frequency fast Fourier transform. So what is the difference between the DIF and FFT algorithm in stage 1, stage 2 and stage 3? That's the reverse process of the DIF-FFT algorithm. Okay, that is the sequence order is in the normal order and the output sequence is in the bit reversal order. Okay, let me see how to compute the DFT for a given sequence using DIF-FFT algorithm. First, draw the 8 lines based on the number of samples. Here, in case of decimation in frequency, the input sequence should be in the normal order. Okay, that is, as I told, the order is just opposite to the DIF-FFT algorithm. Whereas in case of output of the DIF-FFT algorithm, the order is in 0, 1, 2, 3, 4, 5, 6, 7. But the input of the DIF-FFT is in bit reversal order. Okay, so when we complete all the 3 stages, the output is in the bit reversal order. So while writing the output sequence, you should be very careful in writing the sequence. Okay, so the input sequence is in the normal sequence for decimation and frequency FFT algorithm. X of 0, X of 1, X of 2, X of 3, X of 4, X of 5, X of 6, X of 7. The sample is 1, 2, 3, 4, 4, 3, 2, 1. Okay. So in case of decimation in frequency, it is an reverse process of the DIF-FFT. In stage 1, that is one butterfly. That is, one line should be from the even and another line should be from the odd. Okay. It's a simple reverse process of the DIF-FFT. You just add 1 plus 4, 5, 1 minus 4 minus 3, that is addition and the subtraction. Second line of the even and second line and that is the second line and that is the x of 1 and the x of 5. So this is x of 0 and x of 4. That is 2 and 3. 2 plus 3, 5. 2 minus 3 minus 1. That is the subtraction and the addition. That is 3 and 2, 5, 3 minus 2, 1. The last line 4, that is x of 3 and x of 7. 4 and 1, 4 plus 1, 5 and 4 minus 1, 3. So this is the end of the stage 1. So after completion of this stage 1, you have to multiply with the trivial factor. So after this single point DFT, you have to write the trivial factor, that is 8 point, W08, W18, W28 and W38. So you know that W08 value is 1 and W18 value is 0.77 minus I 0.707 and W28 value is minus I and W38 value is minus 0.707 minus I 0.707. We just multiply it, minus 3 into 1 minus 3 and then minus 1 into this, that is minus 0.707 plus I 0.707 and then 1 into minus I minus I and then 3 into 0.717 minus I into 0.717, that is 2.121 minus I 2.121. Okay. Then the remaining thing you have to write as it is 5, 5, 5 and 5. So these are the inputs to the stage 2. So these are the input samples of the stage 2. That is 5, 5, 5, 5 minus 3, and then multiplied samples with the Tudor factor. So these are the inputs to the stage 2. So in stage 2 we have to take the alternate lines, that is x of 0 and x of 3. So x of 0, the input sample is 5 and 5. 5 plus 5, 10. 5 minus 5, 0. And for second, 5 plus 5, 10. 5 minus 5, 0. Similarly for next, another butterfly, minus 3 and minus I. Minus 3, minus I. Minus 3, minus of minus I plus I. And then 0.707 plus I 0.707 plus minus 2.121 minus I 2.121. So that is the answer is minus 8.828 minus 1.414 and then 1.414 plus I 2.828. Then in stage, the next of this we have to multiply with the Tudor factor. That is in stage 2. The Tudor factor value is W04 and W14. The value is, the Tudor factor value is 1. For W14, the Tudor factor value is minus I. And similarly for this W04, the Tudor factor value is 1. And for this it is W14, the Tudor factor value is minus I. We have to multiply with this 0 into 1, 0 and 0 into this 0. So whereas in case of minus 3 plus I, that is minus 3 plus I, and then this one multiply 1.414 plus I into minus, that is minus 2 point I into I square minus into minus plus 2.828 minus I 1.414. The remaining things you have to write as it is. That is 10, 10, 10, 10, 0, 0, and then this one 3 minus I, and then this one minus 2.828 minus I 1.414. So these are the input samples to the stage 3. The stage 3 is a single point, that is the single butterfly, that is a 2-point DFT. So to come to the 2-point DFT, we are going to take the first lines, 2 lines. This one is, and these 2 lines, and these 2 lines to come to the DFT for the each sequence. There is a 4 butterfly in the last stage. Okay, in the last stage, the input sample is 10, 10, 0, 0, minus 3, minus I, minus 2.828, minus 1.414 I, minus 3 plus I, and then plus 2.828 minus I 1.414. These are the input samples to the stage 3. So in last stage, you just add the 2 samples and subtract the 2 samples. 10 and 10, 20, 10 minus 10, 0. This one 0 plus 0, 0, 0 minus 0, 0. And for this, add these 2 input samples, minus 5.828 minus I 2.414, minus 0.172 plus I 0.414, and this one adding this minus 0.172 minus I 0.414, and the last sample is minus 5.828 plus 2.414. So as I told in the beginning of the video lecture, that is the output sequence is in the bit reversal order. That is the output sequence is x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3 and x of 7. So while writing the output sequence, you should be very careful in writing the output sequence. So from this, the value, the output x of k, in the sequence, while writing the sequence, you should be in careful. That is, the output sequence is in the bit reversal order. That is 0, 4, 2, 6, 1, 5, 3, 7. So x of k, that is the output sequence. X of 0, that is 20, What is the fourth? 0, that is the 0, 4, 2, 6, 1. So this one is the 1. That is minus 5.828 minus I 2.414. Okay, and then 0, 1, 2. That is the second position. 0, 4, 2, 6. 0. And then 0, 1, 2. Next one is a 3. 1, 5, 3, 7. That is the seventh position. Minus 0.172 minus I 0.414. 0, 1, 2, 3. And then fourth position. That is fourth. 0. That is 0, 4, 2, 6. Fourth. Fifth position. That is 1, 5, 3, 7. That is minus 0.172 plus I 0.414. Then sixth position, that is the last one, 0, 4, 2, 6. And then seventh position is the last, minus 5.828 plus I 2.414. You can easily verify the answer. That is, when you add all the input samples, it gives the first sequence of the samples. That is, when you add all these things, it is equal to 20. So for the first sample is right. And second one is, all the remaining samples should be the conjugate to each other. Minus 5.828, that is 1 and 7 is conjugate to each other. And 2 and 6 is conjugate to each other. 3 and 5 is conjugate to each other. From this, we can analyze our answer very easily. Thank you so much. Thanks for listening.